Hello all. In this video, we will study how bitwise left shift operator works. So consider this simple example. Suppose we are given a variable x which is unsigned integer. So it only stores non-negative values, right? And assume that the memory required for unsigned integer is 2 bytes. So if it is 2 bytes, we know there are 16 bits. So these are the 16 bits which are shown over here, right? Now what I have stored over here is 12. What I have stored over here is 12. Now we know that 12 in binary is 1100, right? 12 in binary is 110. So that's what I have written over here, 1100. Right? So least significant bits are all 1100 and the most significant bits are all 0. Right, so these are the zeros we have. Okay, now if we want to print x left shift by one position, so we are basically shifting all the bits of x, to left by position 1. So what is going to happen over here is like this, that each bit of x, so these are the bits which are given for x, each bit will be shifted to left. So you can see this bit will come over here, this bit will come over here, this bit comes over here, this bit comes over here, this bit comes over here, and so on all the way down the line. This bit will come over here, right? So I hope you have understood this factor, right? So all these bits will be shifted to left by one position. Now there is a vacant position over here. This vacant position is filled by 0. This vacant position is filled by 0. So I hope you have understood how we are shifting each bit of x to left by one position. So when we do this and when we see what new value we get, and if we convert this resultant value, into decimal, what we get is 24. Right? This is the original value for 12, but now what you get is 24. Okay. Similarly, if you take the next statement, wherein now each bit of x will be rotated to left or shifted to left by 2 positions, then what's going to happen is this 0 will come over here, then this 0 will come over here, then this one will come over here, then this one will come over here, right? Then this 0 will come over here, right? And so on down the line. This 0 will eventually come over here, right? So each bit is shifted left by 2 positions. Then we will have 2 vacant positions over here, and those vacant positions are always filled by 0. Right? So what happens is we get a new binary value, right? Right? And when we look at this binary value, and if you convert it to decimal, then it would be 48. If you convert this binary value to decimal, it will be 48. Finally, we have print x left shift by 3 positions, right? So with same analogy getting continued, what will happen now that each position, each bit of x, right, each bit of x will be shifted by 3 positions. So this 0 will come here, this 0 will come over here, this one will come over here, this one will come over here, this 0 will come over here, and so on down the line. This 0 will eventually come over here, right? So by doing this, each bit is shifted to left by 3 positions, and when you do this, you get a new binary value. You get a new binary value, which is this one. And when you convert this binary value to decimal, you get 96. So you must have observed some pattern over here: 12, 24, 48, 96. Right? So when you left shift by 1, when you left shift by 1, it is equivalent to multiply by 2 raised to 1. Multiply the value of x by 2 raised to 1. So our x was 12, so it was 12 into 2, which is 24. Then left shift, oops, I made a mistake, left shift, no? Left shift by 2 is equivalent to multiply by 2 raised to 2. Multiply x by 2 raised to 2. So it is actually 12 into 4, which is 48. And when you left shift by 3, it is equivalent to multiply by 2 raised to 3. Multiply x by 2 raised to 3. So 12 into 8, which is 96. So in general, right? In general, if you take x and if you left shift it by n positions, then it is equivalent to multiply x by nth power of 2. So this is what you should remember, right? Because you will be given any value of x. So x left shift by n positions is equivalent to multiplying x by 2 to the power n, right? And that is what is happening over here, as you can see. Okay, I hope you have understood this left shift operator, right? In the next video I will talk about bitwise right shift operator. Okay, I hope you have understood. Thank you.